Hello again, this is Angelus from Elite PvP recording tutorial 4 part 2 of the tutorial series Let's Make a Memory-Based Bot. In this tutorial we are going to hook the receive function. Now, in part 1 we found the function and right now I'm right where we left off. I have all the debug open and I'm right at the instruction that I referred to and that I said that I'm going to hook. But we're gonna make some like minor changes here, and I've changed my mind. I don't want to hook this call or replace this call anymore, but instead we are going to hook this call right here, and that is just to manipulate the results of EAX when it returns from this call. So the reason I'm going to have to change the value of EAX when it returns is that I want it so that if EAX equals let's say 0, instead of the program executing this code and returning, I'm going to change the value of EAX to 1, and instead it'll jump right here and it'll read the packet length and the packet buffer off of these addresses, which I will write into these addresses. So it finds that yeah, there is a packet and it processes it. So this way I can like uh, I can make it act like we sent a packet from the server to it, but instead I will be sending that packet from my own program, from the bot project that we're just building. Now, enough talking and explaining, and let's get to work. Now, I'm going to switch to the bot project folder, and I'm going to open CB helper, open the project, and I'm going to start hooking that function. Now, first thing I'm going to do, I'm going to open hooks.h. Now, inside hooks.h, I will define some stuff, and we're going to be use those things to hook the receive function. Now, the first thing I'm going to do is I'm going to copy these 3 lines right here, and I'm going to paste them right underneath. And the only thing I'm going to change is instead of outgoing packet, I'm going to name it incoming packet. So it's just going to change into the word outgoing to incoming. And let's copy this, paste it for the rest of these 2. Okay, now one more thing I'm going to need is another void, so we can call it from our program. And it's going to be called, never mind, I just had it here. You're gonna have to create it. Pretend that this isn't there. Anyway, I made some testing stuff here, and I'm going to redefine it now. It's going to be static void, and it's going to be called receive underscore packet underscore hook, and also it's going to be a void. Now that we defined these, we need to also tell this where they're defined, and we're going to just have to copy these and open hooks.cpp, and right underneath this I'm going to paste the void right here, and I'm going to tell this where it's defined. It's defined in hooks.h. Now this call right here is going to be the call that will be called from our program instead of this address right here. Instead of this address, it will call the address of this function, and this function will call that address. Now, the most important thing that we make this a naked void. So, now that we've done that, I'm going to switch back to hooks.h, and I'm going to copy these, and I'm going to switch back to hooks.cpp, and I'm going to paste them underneath those. erase this static keyword because we don't need it in here. Tell it where those are defined to, and they are in hooks.h. And I'm going to do one more thing. I'm going to make sure all of these are initialized or whatever to zeros, so it'll just set these to zeros. And if you don't have these the same way, just make sure they're set to zeros too. It's not a big deal, I just wanted to do that anyway. Next step is to start with the assembly code inside this function. Now, like we said, this function is going to be called instead of that address that we're going to patch, and inside this function here we're going to have to call that address. So the first thing to do is to use the underscore underscore ASM keyword. Now inside this, what I'm going to type is the following. First thing I'm going to have to do is to save the return address. Let's go back to Ole. Now, when you call a function, the return address will be there right after that call. So I'm not going to do that now. Anyway, so these are return addresses where it says return from to. These are just return addresses. So to return from a specific function back to where that function were called, we're going to have to return to the return address on the stack. So what we do is pop that return address into our own defined variable to save it, and then we push it back right before we return so it knows where to return. Now, to do that, I'm just going to type pop, and I'm going to pop it into incoming packet return address. Now, next step is to call the address, which is this one right here, that we're going to patch. That's the first thing I'm going to do, call this address. Now, how do I get this address here? Okay, I may have rushed the thing and went straight into the function itself that it's going to be called, but first I think I was supposed to find this first programmatically, and then I can start patching stuff. Okay, let's do that now, and we're going to leave this the way it is for now, and I'm going to switch to source files, basic stuff, and I'm going to open cbhelper.cpp. Now, never mind that yours might not look the same and it doesn't have those region and region stuff and crap. I just did these to make it look a little nicer. Now, but the source code itself right here, nothing has changed. These are just to find the send packet function, and you can check that code in, I think, tutorial 3. Yes, tutorial 3 part 2. Yeah. Now, we're going to have to do the same thing we did here to search for the receive packet function. How do we do that? Now, first thing, we need a bunch of bytes and a certain number of bytes that we are going to look for, and based on those bytes we can start tracking our function. So let's go back to Ole. Now, we said that we're going to patch this call right here. Now, it doesn't matter. I can either copy a few instructions above it or underneath it, as long as I'm still close to this call that I'm going to patch or replace. Now, for this tutorial, I'm just going to make it a quick demonstration, and I'm not going to find something specific that are truly unique or something. I'll just copy any bunch of bytes and make sure the program is finding them. But when it comes to searching for a code pattern, you need to make sure first thing that there is no numbers in the after the registers. Let's take this one for example. It says it's just requesting this address, which is ABP -4 off of the stack. Now this right here, the -4, is bad. We don't want that. Also, we don't want stuff like +4 14 or plus any number, minus any number. These are not static stuff. It might change anytime. It's not constant and it might change anytime. So the more you avoid these, the more likely you're going to find the function. Like this right here, it says EBP plus 1600. This number, 1600, might change anytime soon, at any patch. So you might want to avoid this. But for demonstration and for this tutorial, I'm just going to copy anything. So I'll just copy these bytes. Okay. I'm going to copy these instructions, right click, edit, but instead of copying as a table, I'm just going to copy them as a binary copy. And then I'm going to switch back to our program right here. And I need to make them C++ friendly to do pretty much the same thing we did here. So I've made a file, a random stupid file. I called it delete me. It's called right there. And you can see it's empty. And the purpose of this file is just to pretty much paste the bytes that I just copied. And instead of pasting the stuff one at a time, I can simply just find and replace by finding the space and replacing it with these right here. It'll do the job for you. It's way faster. Anyway, that's just out of laziness, but yeah, it's good. Anyway, I'll just undo everything, go back after I copied my bytes, and I'm going to do the same thing we did here. So above this, I'm just going to type this unsigned jar, and I'm going to call it receive packet underscore bytes. Yeah, bytes, same thing as the send packet, and it's going to equals the bytes that I just fixed or copied. Now one more thing I need is to count these bytes, because I'm going to call the find pattern function, and it has to know how many bytes it's going to compare and look for. Now let's count these bytes: 2, 4, 6, 8, 10, 12, 14, 16, 18 bytes. So basically I'm going to be searching for 18 bytes. Okay. Now, next step is to find those bytes. So I'm just going to pretty much copy this line here where it finds those, and I'm going to paste it above it. I'm going to change the word send to receive packet address, and it's going to find, instead of the send packet bytes, it's going to find the receive packet bytes, and instead of searching for 8 bytes, it's going to search for 18 bytes. Also, I need to find a different start address and a different end address. So to find those addresses, I'm just going to switch back to Ollie. Now we know we're going to patch this call right here. So what I'm going to do is scroll a little up this model, and I'm going to make sure it's a fair amount of bytes. I'm just going to right click, edit, copy address. I'm going to switch back to my program, and this is going to be my start address. So it starts searching for the bytes at an address above those bytes. So next thing is to find an address below these bytes. So I'll just hit the star button to go back here. This is the call we're going to patch. So I'm just going to scroll a little down, make sure it's a fair amount of bytes too, and I'm just going to edit, copy address. I'm going to switch back to our program, and I'm going to paste it as an end address. Now remember again that the bigger the difference between the start address and the end address, the longer the program will be searching for these bytes, and therefore the longer it will take to start. So the program is going to be kind of like slow to start up. So you gotta keep it like simple. Don't search the whole process for these bytes. Okay. Now, one thing left is to test this and see if it really found these bytes. And if yes, we can continue. Now, right here, I'm checking if there's this returned sent packet address. If not, I'm printing a message to the console screen to let me know that it did not find those bytes. So I'm going to pretty much copy this line, and instead I'm just going to paste it here. And instead of searching, checking for the sent packet address again, I'm just going to check for the received packet address. And if no received packet address were found, and this function returned -1, I'm just going to print it to the screen real quick to let me know that it didn't find the receive function address. So I'm just going to change the word send to receive. What was that? And am I typing receive right? Whatever, it doesn't matter. So, and one more thing I'm going to do, I'm just going to copy this line right here, or without copying it, I'm going to go underneath this to that console write line, and I'm going to print the receive packet address in case it found it. So, even if it didn't find it, I'm just going to print it to the screen just to make sure that it's what's the result that were returned from the find pattern function, and it's going to print the receive packet address. Now, one thing I'm going to do now is to test the program before doing anything else. So I'm just going to build the program, and I'm going to switch back to our folder where we're saving the DLL and the exe file. And it's going to be right here. And I'm going to start it and see what happened. Okay. Receive packet address 6D89A9. So let's switch back to Ollie and confirm that it's the right address or not. So I'm going to hit the star button to go back where we were, and this is the address. So if we compare these, this one is 6D8998, 6D89A9. So something went wrong. No, not really, because A9 is right here, and exactly that's the address we asked it to look for. So it found these bytes, and the address is correct. But how do we get to this call right here? All I gotta do is simply, not this call, I mean, one second. Right here, I'm supposed to patch this call right here. So I gotta count these bytes all the way up. Okay. So the address that it found the bytes at is this one, 6D89A9. So what I'm going to do, I'm going to start counting the bytes above it until I reach this address here, or this call. So this line is 5 bytes. These are 5 bytes plus 3. That's 8, 9, 10, 11, 12 plus 4. That's 16 plus 1, 17. So 17 bytes, and it'll land us at this address right here. So now if I switch back to our program and I type -17, it should print that address right here. Please go back. Yes. It should print this address right here, which is 6D8998. Let's try and build a program. And it's not going to let us because it's already running. Now I can build it and start the program again. Now let's switch back to the console screen, and it printed exactly the same address, 6D8998. That's perfect. Now that we've found the address we want to patch, the next thing I'm going to have to do is extract this address right here from this number here, which is the binary code for it. How do I do that? I'm going to switch back to the program, and it's going to be this way. First, I'm going to have to go to the properties.h. Where is it? There it is. Properties.h, and I'm going to define this, which is, it says static int receive packet original address. All you gotta do is simply copy this line above, right here where it says send packet original address from tutorial 3, paste it, and instead of send packet original address, it's just going to change to receive packet original address. Okay, now copy this, close the properties.h and open properties.cpp, and I'm going to paste this right here, and I'm going to tell it that it's defined in properties.h, and it's going to also equal 0. Now we're going to use this to store the address that we're going to call, which is this address right here, after we extract it. Now I'm going to go back to my program. I'm going to go back to cbhelper.cpp, and next step is to extract that address. Now I'm going to do that underneath this whole thing. Okay, I'm just gonna type real quick. I'm just gonna start a region and end a region. I can't even type while talking, and it's going to be called receive packet patch. Yes, that'll do it. And I'm going to end it so end region. What the heck? And we're going to place our code inside these. Now, first thing we're going to do is to extract the address. How do we do that? Now we're going to type properties receive packet original address equals ASM, and we're going to extract the address at a certain address. Now it's going to ask me for the current address, which will be receive packet address minus 17. Let's just copy this. That's going to be our start address, and the end address is going to be receive packet address minus 16. It works backwards, unlike the receive packet or the send packet function extraction thing, because right now we are counting upwards from the current address that we just found. In the send packet we were counting downwards, like starting from the bottom of the call to the certain address that we want to find. Anyway, you'll figure it out. Just play around with this and you'll figure out how it's working and what it does. Anyway, now that we've done that, once it finds that address or extracts it, it's going to store it here in receive packet original address, and we can call this inside the hooks.cpp right here inside our function. So that's good. Now let's build, before we build this, I'm just going to paste it or print it to the screen real quick, and it's going to say receive packet original address. You don't have to do that. I just like to make sure we're on the right path or right track here. Sorry, I made a mistake here too, and it has to say properties before this crap. Okay, I'm going to build it, and I'm going to test our application. Okay, start, and the address is 608353. If we switch here, 608358. Yes, exactly, that's the address, and we're good to go. Now I'm going to switch back to the project. Next step is to, I think that's it for now, but let's do this real quick now. As long as we're here, let's just patch that address. Now, to patch that address, pretty much the same thing we've done here, but instead of passing the client hooks send packet hook, we're going to patch the receive packet hook. pass the receive packet hook. Yes. So we're going to go back here and we're going to type the following. I'm just going to delete this for now. We don't really need it. ASM fetch address. Where is it? There it is. And it's asking me for the destination address. And the destination address will be, if you guessed by now, it's going to be receive packet address minus 17. Same thing. Exactly the same thing we did in the for the receive packet function, except the number of bytes had little changed. And the function that it's going to be called instead of that call is going to be client hooks, and we're going to pass the receive packet hook, and the number of NLPs will be 0. We're not going to place any NLPs underneath that call. Now I can build this and test it, but it'll crash because we have an unfinished code here, so it'll definitely crash. Now I can close this or just keep it open. We might need it later. I'm going to switch back to hooks.cpp, and we're going to continue coding our function. Now the first thing, like I said, is to save the return address somewhere so we can push it back on the stack and return to that address when we're done working inside our function. Next thing is to call the function that we just found. So we're going to call, and we're going to call properties dot original receive packet original address, which is going to be, I'm going to have to do it here because it's not going to let me do it inside that simply chat or whatever. Yeah, it's going to be the receive packet original address. Copy this, and I'm going to paste it right here. Now this will call that address that we stored inside the receive packet original address, and the return address for this call, the return value of this call, will be stored in EAX. So EAX by now, if when this call returns, it should be either 0 or 1. So what we're going to do is basically save the registers first, all the registers, so we can restore them later on when we're done working here, so we guarantee that nothing had changed while our function has been called. Now to do that, first thing I'm going to push AD into the stack. Next thing I'm going to push, this time I'm going to push FD. Google those instructions if you don't know what they do. Now that I've done that, I can start doing my own work here, my own stuff. Now first thing I'm going to do is test EAX. And if you're wondering why I'm testing EAX, it's simply because the program does the same thing here, and it'll test EAX, and based on the result, it'll either jump right here and process a packet if the value of EAX is greater than 0, or it'll just simply clean up after the function and return. So we need to exploit that and like make it work for us. Now I'm going to do the same thing that the program will do. I'm going to test EAX, and based on the result, I'm going to jump to one of these labels that I'm going to define right now. Underneath this ASM structure here, we can use labels in inline assembly. So Google that too if you don't know about it. So I'm just going to type process underscore packet. So this label here will be used if a packet has been really received from the server. But if not, I'm going to create another label, and I'm going to call it process underscore but underscore packets. You can call it whatever you want. Now, up here, we test EAX. If EAX is greater than 0, it means that there's a packet that's been received from the server. And so I need to G and Z jump not 0, and it'll jump to process packet. That will process the packet normally, but it'll add one more advantage to that code here is to give us access to that packet before it processes it. So if there's a packet, jump right here, do the code that will be placed below this. If not, we'll simply jump to what? Jump to this, so we can process our own packets. Okay, I think that's it for this part here, and we're going to start coding the stuff that will process our own packet. Now, I'm going to use the keyword underscore underscore ASM again, open, close, and right here, if we switch back to Oli, when a packet is received, it'll jump right here, and this is going to be the length of the packet, this is going to be the pointer of the packet, and they will be pushed into the stack. So by copying these two addresses, EBP minus 14, EBP minus 1C, we have access to the packet pointer and the packet length. So like, we don't have to really do any math to do this, so it's just easy. I'm just going to copy these lines one at a time, paste them right here. But instead of pushing them to the stack, we're going to store them in our process here, in our program. To do that, I'm just going to type the following. MOV stands for move into EAX, and I'm going to move this, which will be the length of the packet, into EAX. Underneath that, I'm going to type MOV move into incoming packet length, what? EAX. Okay, underneath that, right now what we did is basically store the packet length into incoming packet length. Now we need to store the packet pointer into incoming packet pointer. So move EAX, and we're going to copy the address of the pointer right here. Underneath that, MOV incoming packet pointer EAX. Right now we stored also the pointer into incoming packet pointer. Now we can delete these, and by now we have a pointer to the packet, so we can simply read it, and we have the length of the packet, so we don't need to do anything else. Now, how do I read this packet? I need to read it somewhere in my program. So what I'm going to do is I'm going to open cbclient.h, and right underneath where it says send packet hook callback, I'm going to create another void, and it's going to be called receive packet hook underscore call back. This is what's going to be called every time a packet has been received and ready to be processed. So let's copy this, and we're going to open client.cpp. Yes, cbclient.cpp, and we're going to paste that. Let's paste it right underneath this to keep it sorted. And I'm going to tell it where it's defined. And right here, inside this function, is where I'm going to be reading the packets. So basically, or simply, I can open the send packet hook callback, copy this, it'll do pretty much the same job, and I'm going to paste it right here. Now, instead of what's going on here? Everything is black. Anyway, it doesn't matter. Instead of passing the outgoing packet pointer, I'm going to be passing incoming packet pointer. And instead of outgoing packet length, I'm going to pass incoming packet length. And right here, let's change client is sending a packet to client received a packet. Type length offset 2, offset 0. That's perfect. Now we can go back to our hooks.cpp, and we're going to call owner, which is a CB client, and we're going to call the receive packet hook callback. Now it'll do this trap here, and then it'll store the length into incoming packet length, the pointer into incoming packet pointer, and then it'll call this. It'll go inside this right here, and it'll see that the incoming packet pointer and the incoming packet points are already set. It'll create a byte buffer out of these, so we can start reading the data off of the byte buffer. And then when the byte buffer returns, it'll return simply to this right here. So we don't want that. What we want to do is that we've done our job here. Everything that we need to do is done. So we need to jump over the process but packet stuff, so we make sure it's not going to execute that code too. How do we do that? Now, there's a number of ways to do that, but right now all I'm gonna do is simply I'm just gonna go underneath process but packets, and I'm going to create another label, and I'm going to call it return. Okay, that should do it. And the return right here is just going to, we're going to use the ASM keyword again, underscore underscore ASM, and right here, remember we pushed all data, we pushed FD2, and we stored the return address. So we need to put these back to where they belong. Now we start backwards with these two because, again, I made a mistake in tutorial 2, and I said that the stack is, I don't even know why I said that, but I said the stack is first in, first out, while it's supposed to be last in, first out. So what you push to the stack, last thing you push to the stack, it's the first thing that you're going to grab from the stack. You have no choice. Or you're going to pop from the stack. Anyway, so now what we need to do is pop FD, and then we pop AD, and then we're going to push incoming packet return address, and then we're going to return to that address. Okay, and over here we're going to underscore underscore ASM, yeah, and we're going to jump to return. There's an N here, yes. Okay, so by now it'll execute all of this. If there's a execute this, if there's a packet, it'll jump to this label here and execute this code. Let us do stuff to the packet, and then when it returns from this void right here, it'll jump directly to this right here and return. Or instead of jumping, we can just simply copy this, paste it here, and cancel, not use this at all. So just ASM pop up, push and return. Okay. It'll work both ways, but it's up to you. I'll just keep it the way it is right now. And underneath this, the only thing left is to process our own packets. But we're not going to do that now. What I'm going to do is simply I'm going to have to do one more thing before we can test it. Yes. I'm just going to copy this for now, and I'm going to paste it right underneath this. Yeah, that should be fine. Yes, just for the purpose of testing. Now I'm going to build this, and I have an error. Oh yeah, I'm sorry. We have to fix these numbers to be in hex, not in decimal, and to be C++ friendly too. If I leave this as 14, it'll give me a total different number. 14 in hex is not equals to 14 in decimal. So you just have to fix these numbers too to be the same like they are now. And I can build now. And I'm going to start. And I'm going to try and log in right away. See what's going to happen. Now if the process crashes, we know that something went wrong. But if it survives, we know we did it right. Oops, what just happened? I'm going to close this and start it again. Okay, 7. Again, what is it doing right here? Oops, I'm gonna close it. I think I'm gonna have to close Ole and then try. Hopefully this time it'll work. If I could care, yes, hopefully this will work now. And I'm gonna try and log in. Yes, the annoying message again. Okay, I'll give you a second. Only 1 second. Okay, I'm gonna try now. Yes, I know. Dumb. Okay, some interesting stuff is going on here. Okay, I think we have, yes. Okay, we can see it says client is sending a packet, blah blah blah, the details for that packet, and client received that packet, and the information, the length and the type for the packet. That's cool. Now next thing is to process our own packets. So let's close this and switch back to our project. But before processing our own packets, what if I want to bypass a certain packet? Like, assume that the server sent me a packet that I don't want it to be sent to the client. I want to vanish that. I want it to vanish and I don't want it to be there anymore. I can also do this inside this right here. So let's do that now. First thing I'm going to need, I'm going to go back to hooks.h and I'm going to define one more thing. It's going to be also static, but it's going to be a boolean, so bool, and it's going to be called bypass underscore incoming bypass incoming packet. Yes, that should do it. It will be fine. You can name it whatever you want. I'll just keep it the way it is now. I'm going to copy this, switch back to hooks.cpp, and I'm going to paste it right underneath this. And I'm going to tell it where this is freaking defined, and I'm going to make it equals false, not 0. Yes, false. Okay. Now, why are you acting stupid now? Oh, okay. Now, I can use this to determine whether to bypass the packet or not. So I'm just going to copy this and I'm going to go underneath where it'll be fine if I put it here. So underneath the process packet label, I'm just going to type F bypass incoming packet. It'll check whether it's true or false. I'm going to open this bracket and I'm going to close it right underneath this before the process bot packets. Hit Control KD to sort this. And right now, what's going to happen is if the bypass incoming packet was set to true, it'll go inside this and execute this crap. If not, it won't, and it'll execute what's underneath. But we don't want to do that now. What we're going to do that if there's a packet, it's going to go inside and do this only. So let's cut this right here. It's going to do only that crap here, and if not, it won't execute this, and it will just continue to execute this, which will pop fd, pop ad, push the return address, and then return. And that should make sense if you think about it. Now, it's checking whether this is set to true or false, but if it's true, it'll go inside this if statement and execute this. Before we execute all of this, what we're going to do is right underneath the if statement right here, we're going to type bypass incoming packet equals false. So we're going to set it to false because it's already set to true if we reach this line here. Okay, Now, if you don't do this, and somewhere in your project you set this to true, it'll bypass every single packet that the client will receive. But we don't want to do that, so we'll set it to false and bypass only the current packet. So, I'm sorry, what did I just do? I made a huge mistake here. Okay, we gotta fix it now. I'm sorry, it's just my brain is not functioning the way it's supposed to right now. Anyway, let's just cut this right here, starting from the ASM keyword until owner receive packet. Hook callback, cut this, and we're going to paste it above the if statement. And what's going to happen now is that it's going to store the length of the packet, the pointer of the packet, and then call this to let you know what kind of packet we just received. And then inside this, if you decided that you want to bypass the packet, you set the bypass incoming packet to true. So when it returns from this function, it'll check if the bypass incoming packet was set to true. It'll set it to false, and then it will do the following. It'll copy this and paste it here. It'll, or without copy pasting, just to make it clear for you, we're just gonna use the ASM keyword right here, and we're going to also pop FD, and then we're going to pop AD, and then we're going to push incoming packet return address, and we're going to have to move MOV into EAX 0. That will set EAX to 0, and it'll see that it's 0, and it'll just clean up after the function and it'll return. And last thing, I'm going to return. Now, that's only if it's going to bypass the packet. If yes, it'll execute this and return. If not, if it returns here, none of this will be executed. But if it didn't return and it didn't enter the body of this if statement, it'll execute this, which will only pop FD, pop AD, push the incoming return address, and then return to that address. So, I hope it's clear enough so far. But if not, also, it's fine. You can post any questions, anything that you like to know on Elite PvP, and I'll do my best to answer it. Now, next step is to, we can go ahead and delete this for now, or no, just leave it. Next thing is to process our own packets. Okay, but before I do that, I'm going to test this one more time. And instead of processing every packet, I'm going to try and bypass every single packet that I'm going to receive. So I'm going to back to cbclient.cpp, and I'm going to type hooks without a capital H, and it's going to be bypass incoming packet equals true. What will that do is just set the bypass incoming packet to true, and therefore it's supposed to not process any packets, and we'll see what's going to happen. So we're going to start the game again and try and log in, see what kind of messed up thing we just did. Type my password, and I'm going to log in. See, nothing happened, it just froze because we're not really receiving any packets. And if you can see, the server is busy and blah blah blah. But because we bypassed this packet, which will be the very first packet that will be sent to the server, to the client just decided to not to let us in or send anything back, because packets work in sequence or whatever. Just look up the login sequence, packet sequence. Anyway, I'm going to delete this now, build the project, and log in again to confirm that everything works the way it should. Now I'm going to re-log in. I should remember this instead of keep changing 5 to 7. And I'm going to log in. Ta-da! It logs in just fine. That's great. Now I'm going to close this, go back to our project. Now we know this works. I'm going to go back to hooks.cpp. Okay. Now one thing left is to process our own packets. Now how do we do that? First thing, I'm going to be using one of three things. You can use dictionary class, which is located in the header files, basic stuff, and it's called dictionary.h. You can use that, or you can download the uh, evolution bot project off of Elite PvP, and you can use the list class that's included in that project in this project. Or option 3, which might be a little more complicated, which is to use a vector or a list from the std class, which what I'm going to do right now. So what I'm going to do, I'm going to switch to hooks.h. The bottom of this class, I'm going to type vector, and we're going to pass a byte buffer into this. If the byte buffer.h is not included in your hooks.h, you gotta include that. I included this, and it's going to be a pointer, so okay, and it's going to be called packets. Yeah, you can call yours whatever, packets to send or packets to whatever, call it whatever you want. I'm just going to make sure this is static, and it's going to say std before vector. Okay. And I can also make a void here. It's going to be also static, and it's going to be called add whatever, just add packet. Again, feel free to use any names you like. I'm just using retarded names, and it's just going to be called buffer. And I think I'm just going to declare it somewhere else. Let's just keep this the way it is. It's going to be a void. Sorry. Okay. Now, the reason I did this is that I need to call it somewhere in the program and to add a packet, and it'll process that packet when it has a chance to do so. So I'm just going to copy this, switch back to hooks.cpp, scroll to the top. I'm going to add it all the way in the top of this. Again, it's going to be defined in the hooks.h, and inside this I'm going to do the following. Now we've added a vector called packets, so I'm going to, you can either add the packets to the bottom of that vector or add them to the top of that vector and process your packets accordingly. It depends which way you choose, and you have to process the packets the opposite way. So if you choose to insert any new packets to the bottom of the list, you're going to have to process packets from the top of the list. But if you start adding at the top of the list, you're going to have to process the packets from the bottom of the list. So they're all in sequence. Nothing's just mixed up. So to do this, I'm going to start to code this so it adds to the top of the list. So it's going to be the following: std vector, and it's also going to be a byte buffer, and it's going to call the I forgot how to spell that. Yes, and it's going to be called, let's say, it. Yes, and it equals packets. Yes, dot begin, because I'm going to be adding to the top of the list. And last thing to do is to add the buffer to the vector. So packets dot insert. Yes, insert. It's been forever since I used the vector, and it's going to take the buffer, or before the buffer it should take yeah, it should take it first and then the buffer. Okay, with that done, that should work for now. Okay, you can collapse this. Now, I'm going to go back to our process but packets label, and right in here I'm going to do the following check. It's going to be f packets dot count, forgot, no, empty, yes, if packets dot empty, or no, it's if it's not empty, yeah, if it's not empty, we know that we have some packets to process. So let's do that inside here. So now we know the packets list is not empty, or the vector is not empty, and we need to process the packets inside it. Because if it reaches this label here, it means that we can process one packet, and then it'll return and do like pretty much the whole thing all over again. So there is a packet, and we want to process it. Now, the first thing I'm going to need is a pointer to that packet and the length of that packet. So remember, we used a byte buffer. So what I'm going to do is type incoming packet length, because it's not being used up here, it's done being used, equals packets, and like I said, we're adding packets to the top of the list, so we need to start pulling packets from the bottom of the list. So packets dot back, yes, back, yeah, back, and we're going to get the get buffer length. That will return the buffer length. So incoming packet length will equals the number of bytes inside that buffer, or we can simply read the an unsigned short off of that buffer, and it'll also return the length of that packet. Now we have the length of the packet. We need a pointer to that packet. How about not getting a pointer, and instead we know here that this is going to be the length of the packet stored in EBP minus 14, and the pointer to the packet will be EBP minus 1C. So first thing I'm going to do is store the packet length in EBP minus 14. So just copy this, starting at this right here, scroll down, and we're going to start using the underscore ASM keyword, and inside we're going to type MOV into EAX, and we're going to move incoming packet length. So EAX will become the length of the packet. Now MOV, paste what we just copied, which is a pointer to the stack, and it's pointing to EBP minus 14, and we're going to move EAX into it. So that'll store the value of EAX into this address right here. So now we stored the packet length. Next is to store the packet buffer. So what we're going to do, instead of changing the pointer in EBP minus 1C, we will copy our packet bytes on that buffer, which is stored in EBP minus 1C. So to do this, I'm just going to copy this right here. I'm going to scroll down. Underneath this, I'm going to do the following: MOV into EAX, and I'm going to move the value of this, which we just copied, pasted right here. The word PTR SS points to the stack. It's going to be EBP minus 1C. So EAX becomes the pointer to the packet. Now I'm going to MOV incoming packet pointer, and I'm going to move the value of EAX into that. So now I stored the value of EAX into the incoming packet pointer. Incoming packet pointer becomes the pointer to the packet. Okay, with that done, now all I have to do is call a function called memcpy. Stands for memory copy or something like that. Google that function if you don't know what it does. And the destination is going to be LP void, and it's going to be the incoming packet pointer, and the source is going to be also LP void, and it's going to be packets. We're going to copy from packets dot back, and we're going to get the buffer from that. So it's going to be get buffer, yes. And the number of bytes, we can simply type incoming packet length, or you can read it from the packet, from the buffer, the back of the buffer. It doesn't matter. I hope you understand what I'm doing here. If not, just let me know. I'll try and explain more. Anyway, what this function will do is just simply copy from this buffer here the number of these bytes into this pointer here, which right now stands for whatever pointer stored in EBP-1C. Okay, one last thing we need to do is that as long as we going to process this packet, which is the last packet in the vector, we're going to have to call packets dot pop back. Pop back will simply erase the last element in that list. It'll just pop it and remove it, and it's not there anymore, and it'll process the next packet after that. Now, that's in case the packets vector is not empty. But if it's empty, we're going to have to do something. So right here, it's going to do this, push back. If the vector is not empty, it's going to process the packet. Okay. If it's not empty and it's going to process the packet, we need to set EAX instead of 0 to 1 right here, because it'll eventually be 0 when we reach this label here. So we're going to have to set it to 1. So what I'm going to do is just simply go up here, right here, and just copy these. Since from ASM to the causing of this, and underneath this, I'm going to paste that. And what will this do? It'll store the length of the packet into incoming packet length, then move it into EAX, because we can't simply move it into a register right into the memory or into an address in the memory straightforward. You have to move it into a register, and then from the register into the address. So we've done that now, stored the length in that address and the packet pointer in the incoming packet pointer, and then we copied the packet to the packet pointer. Last thing, we remove that packet because it's stored somewhere else and it'll be processed. We don't need to keep it anymore. Last thing is to pop FD, pop AD, push the return address. We're going to move EAX 1. So when it returns, it's going to test EAX again, and it'll find it 1. It'll process the packet we just copied, and then it'll return. If there is no packet, none of this will be executed, and it'll simply go all the way down here, pop FD, pop AD, push incoming packet, leave every EX the way it is, and then return. Okay. With that done, we should be able to call the add packet void to add packets to the thing. 1 second, we have an error here. And it says unresolved external symbol, blah blah blah. Yeah, my bad. To fix this, we're going to have to go to hooks.h, and we're going to have to copy the vector and then go back to hooks.cpp all the way to the top, and I'm going to paste it underneath the client here, and I'm going to tell it that it's inside the hooks.h. Now I can build my project. Okay, everything is cool. By now, to bypass a packet, again, I'm going to explain this. All you have to do is set bypass incoming packet to true. If you want to send your own packet, you create your own packet when it's ready, you can use a TQ packet or byte buffer. I use the byte buffer for this tutorial. And then all you gotta do, I'm going to go back to cbclient.h, .cpp I mean, and inside the receive packet hook, I can simply create a switch here, and I'm going to switch based on the packet.read uint16, and it's going to read it off of the offset 2. That will read the packet type. I can switch through that, and let's assume that it's case 10,010, and I want to bypass this packet. Okay, let's say, oh, or forget that. I'm just going to break here. Instead of this case, I'm just going to use case 1012. Okay, you received this packet, and you don't want it to be sent to the client. All you gotta do simply is call hooks bypass incoming packet equals true. Set this to true, and when it executes this, it'll notice that you set this to true. It'll set it to true, and then when it returns, it'll return straight to this right here. It'll see that it's true. It'll bypass the packet and continue. Now, to send a packet to the client, let's say I want to send a packet somewhere else in the process or in here. You can't send packets inside this right here. That'll fuck up everything for you. You just have to send it somewhere else. Like create something similar to this. Instead of sent to server, it'll just be sent to client. I'm going to make a quick example here just to see how that will work to send a packet. And down here I'm just going to create a void, and it's going to be called whatever. We're just going to send a random packet, so I'm just going to call it send to client. Yeah, that will work. And I'm going to pass a byte buffer. Actually, let's just make it this way. We'll initialize the packet here for now, just to demonstrate this. I'm going to copy this, go to client.h, and I'm going to paste it right here. And I'm going to go back here, and I'm going to make it so that it knows where it's defined. Now, assume that this is not called send to client, and it's called, let's say it's called send jump packet, okay? And I want to send a jump packet. All I gotta do is create a new byte buffer. Buffer equals new byte buffer, and the byte buffer length is going to be, let's say, 50. That's going to be the packet length, and it's going to be a jump packet, we said. So buffer, and I'm going to write the length. I had a couple examples in the packets. Where is it? I don't even know where it was, where I put that. I think it's in packets. Yeah, you can look in packets to how to build a packet. But let's assume we're just gonna create hard code a packet now, and I'm just gonna do it real quick. And the type is going to be 10,010, and it's going to be at offset 2. This is going to be at offset 0, and let's say the type is whatever. Assume this is a full packet that I just created. To send that packet to the client, all I gotta do is call hooks without a capital H, and I'm going to call the add packet void, and I'm going to pass the buffer. So that will add the buffer to the packets vector inside the hooks class, and it'll send that packet when it has a chance to send it. Now, hopefully this will work, because that was the plan. And if it did not, we'll figure it out later on, because we're going to be using all these functions later on when we get like a little more advanced in the bot. For now, we're just finding and hooking functions. And I'm not going to test it now because I'm over an hour right now recording this video, so you're going to have to test it on your own and post some feedback. Let me know, did it work, did it not? Just play around with it. And if there's anything wrong, hopefully we'll work on it and fix it. However, uh, that's it for this tutorial, and I hope it was helpful. And until the next tutorial, be safe.